So we are back as announced after a short, it was a little bit commercial break. It was a movie about Baden-Württemberg from our agency Baden-Württemberg International and all the other agencies as we are one. So let's start in the discussion. I welcome on this panel discussion the presenters of this morning session. Starting at my left, Dr. Alexander Viehl, Professor Dr. Tjark Siefkes, Dr. Michael Buchholz, and Dr. Ulrike Weinrich. So thank you for your input presentations. Now we have the possibility to go on a little more, on a few questions more in detail. I would like to start with a short starting round. Let us just imagine a highly automated, connected and sustainable mobility system, which we all want to have in future. What are, from your opinion, from your projects, your activities that you presented, what are the main challenges that we will face in the coming decade, especially in order to bring really autonomous vehicles into the field, onto the road? So maybe we start.
Me first? Personally, I think the main limitations at the beginning were the laws which we were facing and the boundary conditions, considering how you get this shuttle on the road and what you have to do for it. And these are actually, for us, are going to be less limiting once we have the new legislation. And I think this was like the main, I think not fear, but what we were afraid of, what will come the next couple of years. But we're really happy about what's going to happen now and how this is going to help us and other projects as well to bring new types of systems onto the road.
Michael Buchholz?
Maybe I can add that I think one of the main challenges is the transition we will have. At the moment, we have manually driven vehicles on the road, which are mostly not connected, or many of them are not connected. For sure, we have pedestrians, bicyclists, and so on. And if you would switch to a completely connected environment immediately, many tasks of the automation would be much easier. But we have to make the automation work in an environment which was made for the human driver. And I think that's one of the main challenges we have. And there has to be a transition which is, on the one side, still allows the infrastructure owners, like the cities or the countries, still to pay for the additional digital infrastructure. That shouldn't be too expensive, otherwise it's not feasible. But on the other hand, the vehicles have to handle that there are many vehicles on the road which are not automated or which don't get that information. I think that this is one of the main challenges we will have in the transition phase. Mm-hmm.
Yes, I agree with Michael. Mixed operation is the biggest challenge we see. And it's going to be mixed operation probably for the next 20, 30 years to come. So that is one big challenge. The other big challenge is, of course, to make it safe and secure. Just giving one example, you can imagine a family taking an autonomous shuttle, the parents inside, kids outside, the vehicle drives away or vice versa. That is, of course, a complete no-go. And if these things happen once or twice already, then the acceptance is going to drop rapidly. So this is something which we need to address carefully already at the beginning. So there's some tasks in autonomous vehicles, entry and barking, debarking activities, which we have to screen very carefully before we go real life.
Mm-hmm.
Okay, I would like to address as well the complexity of the different scenarios. So I think in the transition phase at the beginning, we will have some, let's say, easier scenarios, maybe slow-moving vehicles, last mile, maybe also in areas that are well suited for such activities. But imagine some cities where you have old towns or a city profile that's maybe not perfect for some automation, maybe because the infrastructure is not properly set, and then you get some acceptance problem because then the vehicles are very slow, or the vehicles stop at some point, or they cannot bridge some gaps where you need then another mode of transportation. And I think for that transition phase, we will also need some support and see what is acceptable and what not, for not damaging the new technology just as it fails at some points.
Mm-hmm. Yeah, thank you. Yesterday, as I said in the introduction, we were discussing a lot about added value, new added value through new components. This was very focused, of course, on it was very much focused on the electrification. Yesterday we were talking about electric motors, about batteries, about fuel cells. I think the technological changes which are coming with the automatization and the connectivity, we already discussed it after your presentations a little bit, but I think the challenges are much broader than through the electrification. So for companies in Baden-Württemberg, as we are a region which really has grown and really has a very good market position in combustion technology, but if we look at the companies in Baden-Württemberg, so what are the challenges, maybe the opportunities for companies to go into connected and automated driving? Are there new components coming up which will be coming to the market? Are there new challenges, Alexander? Maybe?
Yes. Thanks for the question. So I would like to go from the, let's say, the powertrain. There are also challenges, but I would go really for the automation. I think there will be new or should be new activities towards sensors and also computation platforms. So I think what we see today, that the sensors that are highly sophisticated and used for current, let's say, experimental aspects of automated driving, but also then for the market, still are quite pricey. And also from the perspective of the computation platforms, I think there will be much more edge processing, at least the pre-processing where the data are created, instead of providing everything to a central unit. But also for such architectures, we need new solutions that can be sold on the market and that are efficient. And what we've seen, so in the last discussions, that there are not enough chips for the cars. Mm-hmm. I think that is something that will develop in the next time. And I'm interested also to see how we can support such activities for really having the innovation, but also the products here at Baden-Württemberg, mm-hmm. and not having strong dependencies to, let's say, Asia, for example, mm-hmm. to get such components.
I mean, from the U-Shift, you both are involved in the U-Shift project. This is a complete new concept of vehicles. So,
for me, it's a déjà vu. Mm-hmm. Roughly 10, 15 years ago, we started in Germany to deploy Industry 4.0. And for the big companies, it was already a struggle to get this implemented. For the small and medium-sized enterprise, it was at the beginning a disaster. There was no manpower, not enough brain power there, expert missing on a large scale. And this I see again here in this activity, trying to make mobility 4.0. We still miss the brain power for this. So we need to qualify small and medium-sized companies to take the pace which is necessary. It's going to happen fast, but still be in contact also with the OEMs. The OEMs will define the pace, and our task is definitely to ensure that the small companies don't lag behind.
Yeah, maybe I can add, because you asked for the U-Shift concept, for example. I think this will be also a great opportunity for companies coming up with new ideas. If you look at the capsules, which are part of this traffic concept, even if you're not part of the drive board, you can think of very many different capsules which you can provide and offer for different services. an office capsule or whatever you can think of. So I think there are also great opportunities which you can have. And I also agree with Alex that sensors is a very important topic, and also the electronic control units for the vehicle, which have to be very energy efficient on the one hand. But as you have seen from all the talks here, I think we all integrated infrastructure as information somehow. So there's also a great opportunity in developing new sensors, control units, and so on for the infrastructure side. So it doesn't have to be on board the vehicle necessarily.
Ulrike, in Rabus project, you're working together with ZF. You mentioned, so maybe it's a new role for a supplier who is in this case much like an OEM itself.
Yes, ZF becomes an OEM at this point because they are the ones together with to get there, getting the shuttles on the street. And I think what they really need are the testing kilometers. They need the data. They need to really see how the shuttle drives on the road, how it is connected to the infrastructure, and how it's maybe even speaking, let's say like this, to the people surrounding it, because just because the shuttle knows it's going to stop, how do the people on the street know that it sees them and that it's actually going to do something to stop? So we really interested in this kind of data, and we need to use that to improve the system, and especially in a project like this, give the opportunity to others to use these data as well. So.
Data is a good word, it's a good point. Yesterday we had a part of the panel discussion exactly 24 hours ago was really about the whole topic of necessary data. Of course we had I think FZI is also involved in the KISME project that Dr. Scheer explained us yesterday. Of course, you need data, you need to analyze data. Artificial intelligence can be a method to analyze this data, but of course, we already talked about the legal framework, then we have data protection regulations, we have security issues and everything. So maybe let's talk about this whole connection of, also again, opportunities and maybe just a few threats for the whole development. Maybe we start with...
Thanks. Yes, so as I've shown in my presentation for the test area, what we do, of course, have is plenty of sensors. And especially when it comes to GDPR, the video sensors are problematic. However, if you think about AI, meaning most likely machine learning in the past years, you need data to train something. And now we would have the challenge, okay, on the one hand, it's a technical challenge because we can produce so many data that we cannot even store them. This means we need to be selective, and we need to take care about the GDPR. But for example, if you would say, okay, you're using some measure to grant privacy in stored data, but later on you would like to use those to train something that is related to the human individuals. For example, to train something about intentions of pedestrians. But then you cannot train it based on some pixeled images of the faces or so. So this is something where also we from the research side need to provide measures. On the one hand, how to deal with the big data. On the other hand, how to use them afterwards, because often if you could store the raw images, you do not have even an impression what you would do with them maybe in 2 years. Mm-hmm. And that's why you cannot use them as they are, and then you need to take some measures for the privacy, and then maybe you're reducing the value of the data you have.
Yeah, maybe I can add that I think the start, having the European regulation on privacy makes the start now a little bit harder for each of the partners working on that data, like Alex said. But in the end, I think we will come out of this with very good solutions which respect the privacy of the users. And I think in all over the world, if once the technique is established, all the users will ask for privacy. In the beginning, if it's something is new, it's cool, you want to try it and you don't ask for privacy. But if you're using that regularly, privacy becomes more and more an issue. You see that in the States, but you see that also in Asia, for example. And so I think this is even if it's like a barrier in the first step, I think it's a good starting point for the follow up when the technologies are established on the market. So I don't see this as a big problem. It's a challenge for sure, and we have to handle it as a research institution together with our partners from industry, which doesn't make it easier if you have different roles in a project to share data, for example. But you find solutions for that. It's time consuming, and you have to discuss with lawyers and all that, but in the end, I think we will find solutions, as also Alex said, we will, and on the technical side, we will also find solutions how to store the data. We cannot store everything, but we will have measures to select which data is important and which is not. And this might also be, using AI to decide what is important and not. And then we will store that in a manner that it respects privacy for the users in the end, I think.
Maybe it will be a part of the Rabo's work with the users, of course, that, always the question, I want all the data of the others to plan my way, but I don't want to share my own data.
Yeah. It is important to communicate what we actually want to do with this data to the public, because if we just keep it to ourselves and then maybe at some point we just say, oh, here's a camera, just for your knowledge, that won't bring us to the acceptance we are looking for. We're really looking for showing them what kind of CCTV we have installed and what the CCTV is actually recording, and how we maybe even blur some kind of areas just for everyone to be safe or to feel safe. And then to show them what the benefits are, because this is the same with when you're using your mobile phone and device, and you have this app, and the app shows you what you can actually do with all the data you give them. This is what we're gonna try to do with Rabos as well, that we try to show what benefits come from giving us this data, so that the vehicle gets more and more safe and secure and is reliable at the end.
I mean, at the moment there are a lot of political, industry, research-driven activities to gather data in data spaces on the European level. Gaia X is one word, and a few weeks ago there was an announcement. Now it's called Catena X. It's an activity to gather more production-oriented data, really like a data-driven value chain. There are activities bringing together research data. How important is it for you as researchers to have these data spaces? Maybe Tjark, Siefkes.
Of course, it's important to understand the data. Adding to what my colleagues here just said, especially Ulrike, trustworthiness is one big question here. What we have is not the first time that we look at automation. We have automation, fully autonomous flying already in place. We have autonomous public transport on rails in place. And there we already have CCTV. We have CCTV in stations, in airports, inside the underground trains, etc. And there's not a discussion about these CCTVs currently because they're trusted to a certain extent. They provide security. And we have to take the same step forward in automotive applications. We also have to ensure that the same way how it is used in public transport on rails, it's going to be used in public transport on cars as well. Then we already have taken a biggest hurdle, next step there. Data is more important on road transport because road transport is more complex. So the analytics behind this require even more data. We have more scenarios than on rails, rail is just two-dimensional. In the cars, it's really three-dimensional, what we have to focus on. So the artificial intelligence we put behind this is much bigger and requires, for statistic reasons, also more data. So as researchers, we definitely need more data, but on the other hand, we have to deal with this data as well as we dealt with it in aerospace applications and rail applications.
Okay, then maybe I take the chance. So I think it's also, apart from how to use data, it's also an efficiency question how to provide data. Because if you look back into the past before those initiatives existed, everybody who needed data had its own infrastructure and its own interfaces between the tools and ways of storing it and ways of querying it. And everybody did the same, but it's not compatible. And now that's also what we saw. So before we had the test area, also at FFZI or data repositories for training some neural networks, for example. And now you see this effort with the test area, and there are also other partners and other experiences. And I think if we achieve at least to get there some standards, maybe not just to share all the data, but at least how does a data repository look like? How does a query look like? How does a meta description of the data inside a repository looks like? Then we could also have some innovation steps, because then there could be some companies that would offer their services, their digital adding value based on those standard interfaces, and could ease up for the people or for the companies who are just interested in that it works. They don't need their in-house scripts for each and everything. They don't need their own IT making backups of the databases. But if you have this, let's say, common interfaces and common language, common architecture, then you could also have an efficiency gap removed, and you could have additional added value.
Yeah, standardization we discussed yesterday, and I would have a question to Michael. You are in an European project, ICT for Cars, as you told us, and one point of the discussion yesterday was that it's for companies who work in an international way. It's sometimes really a problem. I mean, of all the regulations on data protection and data security are on a European level, but one point of the discussion yesterday was that the interpretation of these regulations are quite different in different parts of Europe. Do you have from your project any experiences in that? Or?
No, we didn't encounter any problems with respect to that, because our architecture, as I presented, process, for example, the camera data directly at the sensor, and all the data which is transmitted has no privacy issues anymore, because it's just the position, the speed, and the size of the vehicle, for example. And this is the same also in the Italian test site or in the Austrian test site. And because you mentioned standardization, we use standard ETSI messages, for example, for that case. But we also see that standardization is I mean, it's a research and innovation project. So as you probably might know, it's that what we offer as a service within that project is not yet standardized completely. So the messages don't fulfill everything we need. So what we always do in those projects at the moment is to push the standardization forward. For example, for the collective perception message, which is the environment model from either a vehicle or the infrastructure, we are partners of the ICT for Cloud project. Together with our input, are part of the working group working on those standardization, because we need to push that forward and to also further develop. You need standards to be compatible also between different OEMs, also between, if you have older vehicles on the road, they still have to be able to use that data once we think this is already established. But then you will also need a process how to add new services and to change the standards to develop them further. And this is also something which happens at the moment, largely in this area where the message is used for communication between the different communication partners in the infrastructure and on the road it's ongoing, it's further developing. You see new versions or new drafts every 1 or other year for the different messages, which is good.
Just one other point I would like to discuss with you, as you are all representatives from the research sector. It was a topic yesterday in all discussions too. One strength of Baden-Württemberg is always said is the people working in the different companies and in the research institutes. One point yesterday was really that the whole in the education in the universities has to become more flexible and adapt to all these challenges that the technological change brings about. And of course, another question is how to qualify people working in the companies today who have studied some technical topics a few years ago and are now working on combustion technology or other things, how to make them fit for the future. So I would be interested what your opinions or maybe just especially your experiences about these questions are. So I would start with Ulrike.
Yeah, so at the University of Stuttgart, we also already came up with some new studies concerning automated and connected driving or autonomous systems, so that we get the new ways for the students so that they can study in these kind of fields. And there are often studies where few institutes came together, so it's not mainly our Institute for Autonomous Systems, but it's also for the informatics and so on, because the students, I think, need a broad range of knowledge. We can't just deep dive into one topic and then leave out the rest, because that's not what they're going to do in the future when they're working as well. I personally see the problem even further when we're gonna see the transition that's happening, and we're gonna have to come up with some new ways to bring the people who are actually involved in the internal combustion at the moment to give them insights why it might be good to change over to the electric vehicle or even to other fields as well. So I think we already started with it at the university, but we have to come further into the companies as well, so that we can teach the transition there as well.
I mean, I have a very dedicated personal view on that. I think it's very important, and one of our strengths here in Germany and especially also in Baden-Württemberg is that if you did your studies in electrical engineering or mechanical engineering or computer science here, what you normally got from all the universities here in Baden-Württemberg is that you have a very broad base. And this allows you to even make all those transitions, because you have the basic knowledge on a broad field, and you're not a specialist in a technology that might be old in 5 years or so. So and this is also a strength. When I did some internships abroad in Canada, for example, during my studies, this was something which the people there didn't expect, that you have such a broad basic knowledge, and you can discuss with different people in teams with different people, and you understand what they're saying, because they have very specialized studies. So I don't think the solution will be to have very specialized programs at the universities. For sure, we have to add as soon as possible the new technologies to our curricula. But on the other hand, we still have to remain the broad basis, which allows the students to dive deeper during their life after university in different topics which will change, because the basis, maths, engineering basics and all that, these stay the same, communication technology, for example.
So the secret is a broad basis to stay open-minded.
Right. That's my point of view.
What are you?
Yeah, I can add to this. I personally see a big dilemma. What we have here, we all talk about long life development, learning the whole life. So it means also that we have to ensure that people already in the industry have a chance to learn. On the other hand, when I collaborate with OEMs or small and medium-sized enterprises, people are working 120% of projects. Have limited access to kind of additional classes, additional lessons learned to take. That gives the challenge that they are left behind also after a while, working only inside companies. Where I try with the boards of the companies to ensure how can we take them along, how can we take them ahead. And this is also necessary to be done here in Baden-Württemberg, definitely, yes. The other thing, like Michael said, is the in-depth knowledge is not so important anymore. It's a broad knowledge. So what I do when I give lectures, I take the example of my field, of the vehicle domain, but then I teach my staff dilemma management, for example, Six Sigma tools or engineering tools, how to solve system problems. I talk about cultural awareness. So things which broaden the view and enable the students to take any kind of tasks in the near future, because the world is so volatile, so quick changing, that they also have need the possibility to adapt as quick as possible.
Alexander? You?
Okay, yes, I would also like to pick this point, and I think we need some kind of mind shift. Because currently we have a really development where at a broad level we have changes in the industrial structure. You cannot compare it with maybe the beginning of the 80s when the computers came up, but it's now really some disruptive changes that need a broad adaptation. This means on the one hand the mindset needs to change, let's say on the executive business level, to see, okay, there are some new technologies, why not address them and why not send people explicitly to learn something new? On the other hand, we also need the mindset of the employees, because even if you're 120% in the projects, you always need to say, okay, my market value may change, because in the area where I'm an expert might not be sufficient, although I have this broad basic knowledge, but there should be some, let's say, latest high-tech things maybe I should deal with. And that's also, so we are from FZI, we're not directly giving any lectures, although we have the relation to the different universities in Baden-Württemberg. However, what we did is for some, let's say, latest technology findings we have, but that are so mature that we've proven the industrial applicability, we provide some specific trainings that could be hands-on training with 4 persons, or maybe some hands-on workshops with up to 20 persons, really to offer what is from our perspective, and it seems that it's requested from industry, is relevant for them to, let's say, at first maybe just test whether a technology might fit to what they aim to do, but at the end also to have some larger scale training of the employees.
As we have a new state government coming up, maybe for you as representatives of the research field, what are necessary steps for a government just to make the universities, the research institutes fit for? Is it really like framework for funded projects, or are some measures to make it easier to work on qualification of people working in companies, or any ideas that we can now communicate? Michael?
I mean, what we definitely need is a good balance between the different fields, and I think what is especially important for universities, which I would say is a basic funding for the university, which also allows for basic research, which is not directly already an industrial project. So in the last years, we have seen that most of the funding comes from research projects in large projects. You get more money if you are in projects with industry. But the basic research, as we had in electrochemistry, for example, for the batteries, I think in Baden-Württemberg, there were only the last professors in electrochemistry when the batteries came up. So this was a good thing that there was a basic funding also for fields which did not seem very promising to that time, but there was some basic research on that, and this quickly developed into a large branch. And I think we should retain that, and we need enough funding for the universities to allow for that basic research, which is then added by the research of the other research institutes like the FZI or DLR, which are more industry-oriented, and this has to go side by side. But in the last years, we have seen that the basic funding for the university here has decreased compared to the other funding, and I think this is something you should work on, because then you're prepared for the new technologies coming up in, I don't know, 10, 20, or even 30 years.
Yeah, maybe to add, from 2004 till 2017, I was a member of the board of the German Industry Association for Research, Innovation, Technology. And what we saw there is that Germany in general is very well set up for basic research, excellent universities, very qualified work being done. And then we have a very good industry as well. But we see that lots of what has been developed here, innovated here in Germany, has been moved out of Germany for then industrialization into Asia, for example, or even to North America. So we were not that good in Germany, and still are not that good in picking up what has been developed, innovated here into our own industry. And that is where we need help of the politics to bridge that gap. So really to enable us with demonstrators like Rabus is, like U-Shift is, to define and see what technology readiness level is necessary to do the implementation, in the real innovation step, the final innovation step before it comes an industrial product.
Maybe I can add that the current situation, for example, if you have a research project which has a good idea, the current legal situation to start with a startup after a research project is very complicated, because I mean the professors, for example, might not be allowed to be part of that startup because they have their association to the university. There are laws that forbid that. The knowledge is at the universities, and they have to. By law, they have to any company, even if it's a startup, to pay for the knowledge the university has, so that you don't have some money going to industry without control of the European Union. And this is something which makes the startup community very hard from research projects, for example.
Correct, yeah.
And this is something we have to, like Tjark said, we definitely have to gap. And this is a legal problem on the one side. I mean, the laws have their right, because, I mean, we don't want to have corruption on the other side. But at the moment, it's very, very complicated.
Actually, that's a perfect hint to our afternoon session concerning startups. We will discuss with some of the startups in our network, and these are all types of founders, some very young one, but also a little bit more aged. And, that's always a tricky question about finding the right environment to foster startups in Baden-Württemberg. We had that for several years. We have about 2 minutes left, so I would like to come to a short conclusion round. Our former Chancellor Helmut Schmidt once said, if you have visions, you have to go to the doctor, not in politics. Luckily, we are all not politics, so we can try a little bit vision out. So I would like to picture what do you think will mobility look like? You mentioned mobility 4.0. This was my idea. So what do you think will mobility look like in 2050? That's 30 years from now on.
For me, it's important that we still have mobility also for not so rich people. So mobility for everyone. That is at least also based in our fundamental laws we have in Germany. And our task is to enable and keep this going ahead. This is one thing. Secondly, what is important, we talk about decarbonization, environmental footprint, etc. That is only a goal, but the means to it is that we reduce the energy consumption, also in mobility and in other areas as well. So focusing on reduction of energy while providing the mobility to everyone, that would be my vision.
Alexander?
So I think for me it's less mobility. So I think some good thing we learned from the Corona situation is that not each and every business trip is necessary. You don't need to be in office every day. The second point is where I also agree, I hope that mobility will be affordable. This means everybody has access to it. And the third point is I think it will be more or less without any combustion of fossil fuels.
Michael?
I mean, now it's hard to add any new points because you, Alex and Tjark already made almost all points. I also agree that mobility even has to be more inclusive than it's today. It has to be a mobility for everyone and it should enable everyone to be able to consume mobility. But I also agree with Alex that the consumption of mobility has to be reduced if we want to have this energy reduction what Tjark was talking about. So I agree with them.
And last but not least,
I think we should see mobility as a service, and we should really look how we can make it affordable, but still ways to choose from, which is maybe the best way to travel for the people and what kind of transport they're going to use, but without using their own personal car, because as we know, it stands around for, I don't know, 95% of the time. So this isn't really a nice vision for the future, because we could save or we could use this space for anything else in the future.
So thank you very much to all of you. I say thank you to Dr. Alexander Viehl, Professor Dr. Tjark Siefkes, Dr. Michael Buchholz, and Dr. Ulrike Weinrich. Thank you for your interesting presentations, for the interesting discussion. I would have liked to go on, but we can do this at another time.